Okay, let's unpack this. We're diving into Project Hyperion today. It's quite an imaginative study, paints this picture of a vertical Lithuania.
Fascinating concept.
Exactly. And the sources we've looked at, they ask a really key question. How will AI reshape housing? And crucially for you, how does that affect the value of your flats versus, well, land?
That's the core tension, really. The structure versus the ground it sits on.
Right. So our goal here is to distill the main insights, give you something solid to think about for your own strategy. So Project Hyperion starts with this, well, pretty aspirational standard, doesn't it? 100 square meters per person.
Yeah, 100. It's positioned as a real golden standard.
Which is just miles away from the current average in Lithuania, right? What is it, under 30?
Just under, yeah, 29.6 square meters on average. So it's a
Yeah.
huge leap they're proposing.
Yeah.
But what's really interesting is how that idea, that much space per person in a tower, kind of bumps up against a strong cultural preference there.
You mean the preference for single-family homes, owning a bit of land?
Exactly. That's traditionally been very important. And it also makes you ask, is just more space always the answer?
Right. Is bigger always better?
Maybe not. Psychologically, things like really good design, lots of natural light, smart organization, those often count for more in terms of well-being, that feeling of home, than just, raw square footage.
Quality over quantity.
Precisely. It's about the quality of the space.
That's a really good point. And I suppose even when you're building these super ambitious high-rises, there are practical limits, a sort of livability ceiling.
Oh, absolutely.
Yeah.
We see this with the super talls. They're really tall, skinny ones like 432 Park Avenue in Manhattan.
Yeah, I've heard about issues there. Wind sway, things like that.
Exactly. Even with incredible engineering, you hit exponential problems. Noise, movement. It can get uncomfortable.
So Hyperion pulls back from that extreme.
Yeah, the project seems quite pragmatic on that front. It settles on a tower around, say, 200 meters, maybe 60 stories. Kind of a sweet spot.
Okay, so optimal, balanced, not pushing the absolute limits. So we have this mission. Thousands of these 60-story towers, almost 3,000, right? To house 2.8 million people.
Yeah, covering about 70 square kilometers.
The sheer scale is one thing, but then there's the cost. The baseline estimate is, what, 771 billion?
That's the figure, which is, well, staggering. More than 10 times Lithuania's annual GDP.
So using today's tech, today's methods, it looks completely impossible on paper.
But this is where AI, if we connect it to the bigger picture, could genuinely rewrite the economics.
How so? What kind of AI are we talking about?
Well, several things working together. You've got generative design, for instance, AI helping optimize the actual structure, the layout, using materials more efficiently.
Okay, so smarter design from the start.
Then robotics in construction, doing the heavy lifting, the repetitive tasks, maybe the dangerous ones, faster and potentially cheaper. Plus predictive analytics for managing the whole process, supply chains, schedules, avoiding delays.
Reducing the upfront costs.
Yes, exactly. Significant potential reductions there.
Yep.
But honestly, the really massive number, the potential game changer, is in the running costs.
The maintenance.
Yes. The projection is for a potential 40% reduction in annual maintenance costs for these new types of buildings.
40%? How?
Through integrated tech. Think IoT sensors everywhere, monitoring structural health, energy use, predicting when something might fail before it happens. AI managing the building systems in real time.
Wow, 40% annually. That's not just a small tweak. That fundamentally changes the long-term cost of ownership.
It really does. This idea of AI-driven deflation in building and operating costs, it's powerful.
So you take that 771 billion euro sticker price.
And suddenly, the ongoing savings start to make a huge dent. That 40% reduction year after year compounded. The estimate suggests it could shave nearly 180 billion off the total life cycle cost over maybe 15 years.
Okay, so it starts to move from, like you said, impossible towards, well, maybe just extremely ambitious.
It puts it in a different light, certainly. Makes these big visions seem less like pure science fiction.
So if this AI-driven shift in building economics is coming, let's bring it back to the individual investor. What does this mean for, say, your existing flats?
Well, our analysis points towards a pretty high chance of what we'd call relative value erosion for older flats over the next, say, 10 to 15 years.
Erosion. So losing value compared to the new builds.
Exactly. We're calling it a potential quality divide. It's not just that they're old, it's that they won't have these integrated smart systems, the drastically lower running costs.
Okay, so new smart buildings with much lower heating, cooling, maintenance bills, they just become way more attractive.
Inherently more desirable, yeah.
Yeah.
And more economical to own and operate day to day. That difference will likely start showing up in rental yields and resale values.
Is it like a cliff edge for older flats or more gradual?
Probably gradual at first, but likely accelerating as more of these AI-optimized buildings come online and that cost difference becomes really clear in the market. It won't mean all older flats become worthless. Location still matters. Character
But
matters.
their core value proposition gets weaker.
It becomes more challenging, yes,
Yeah.
especially against buildings offering that 40% maintenance saving.
Okay, makes sense. Now, what about the other side of the coin? Land.
Land is interesting. Short term, you could plausibly see a spike in land value.
Why? Developers buying up sites.
Precisely. Developers needing plots for these new efficient towers. But the longer-term view is potentially different.
How so?
As the structures themselves become, in a way, technologically commoditized,
Yeah.
cheaper, faster, easier to build and maintain, thanks to AI and robotics.
The building itself becomes less unique.
Potentially, yes. The technology makes building amazing structures more accessible. So what retains its unique value? The land. That specific, finite, irreplaceable location.
Ah, so the enduring value shifts back to the unique plot of Earth.
It seems plausible. It aligns with that cultural preference for land, too, in a way. The building might be replicable, but the location isn't.
But you mentioned a wild card.
Regulation, always the wild card. How quickly will planning laws, zoning, building codes adapt to this? Will human systems keep pace with the tech? That's a huge unknown.
So, pulling it all together, this Project Hyperion thought experiment really throws a spotlight on a fundamental tension, doesn't it?
It does. It's this battle playing out. On one side, you have technology's amazing power to potentially commoditize the physical structure, making buildings incredibly efficient and cheaper to run.
And on the other side,
The enduring, maybe even increasing, premium placed on unique, irreplaceable location, the land itself.
which leaves a really important question for you, the listener, thinking about your own investments.
Yeah, the question is, as the buildings themselves get cheaper to build, and especially cheaper to maintain year after year, where do you see the true lasting value? Is it going to be embedded in the ever smarter structure, or is it, at the end of the day, all about that timeless, unique value of the land beneath it, something to really consider?